Good day everyone, I hope you are well and welcome to Prota. My name is Nigel Watts and I am the Managing Director of Proto Software based in Kuala Lumpur here in sunny Malaysia. And today I'm going to introduce you to a foundation design capability within ProtaStructure. And in this short video we'll cover some of the capabilities including pad, pile, strip, combined foundations, rafts and piled rafts, and we can even look at soil structure interaction. Now to cover this I'm going to use two tools, Proto Details, which is our structural detailing and drawing management tool, and our core product for modelling analysis and design, ProtaStructure, which covers both steel and concrete buildings together with foundation systems. So without further ado, let me take you through. Now on launching Proto Details, I can directly come into our design library of standard design and detailing macros. And if you come down to the bottom here, you'll notice that there's a macro for pile design. Now this might be a great starting point for being able to look at how we may go about designing our foundation systems. So within the pile design, I can choose from different types of piling systems: circular, square, rectangular, it could be board or pre-stressed spun, and I can define properties like length and size. I may look at a smaller pile here. Let's start with a 200 diameter circular pile. Now in terms of design, we can look at both working load as well as lateral analysis. And I may, for this piling system, be looking to establish a basic working load of maybe 150 kilonewtons, and we may have some nominal lateral loads that we want to consider, which can be applied as shear forces at the top of the pile. Now for soil profile, we can work in a number of ways. If you have soil data, so SPT data, as well as soil classification and depths, these can be directly imported from Excel. Once you have them in here, of course, you can input them and you can make changes to parameters in the software. What we can also consider is effects like grouping. If you have piles close to one another, then you can expect there to be a reduction in capacity, and we make consideration of a number of different theories here: converse, Laber, Los Angeles group action, Seeler-Keeney, or you could choose not to. So let's use the Los Angeles group action, and that gives a group efficiency factor of 0.85. You can also control factor of safety for both end bearing as well as shaft resistance or friction. Now I'm going to work with the SPD data that we have here. If you do want to consider negative skin friction, you can. Now on that basis then I can calculate an allowable working load, and as you can see this is actually less than ideally what we would like to achieve, which is 150. Now I can iterate through this process, so I might go back in this situation and maybe I'd like to increase the size of the pile. Let's see if we can work with a 225 pile and see what impact that has on the design. So if we go back to the SPT data, again I can calculate that out. That's now 161 kilonewtons. And you can look at the diagrams and you can see how the capacity of the pile is increasing with increased depth. If you wish to change parameters in here, design parameters, and move in to look at lateral loading, you can. So I'm going to, it will automatically calculate spring stiffness, and we can then move in and look at designing the pile section for the lateral loads. Now this is a non-linear analysis that I've run, and I'm then looking at the moment and shear based on the values that we've input there. You can see the 8 kilonewtons at the top there, and you can see how the shear force and moment and deflection diagrams are changing as we go down. You also look at the interaction diagram here, and you can see the capacity of the section. So if we come in here, we can also look at the steel that's been provided there. I may want to reconfigure this. Perhaps I want to see if 7 bars would work, and I can make 7 work. So you can play with the reinforcement design in here. But the key results are that the pile has now been designed based on and looking at these different parameters. Okay, so that may be a starting point that we then want to use for working through our pile design within our structural system. And once you're happy with this, you can just hit OK, and you'll get a schematic of both the pile, pile layout, as well as the basic quantities takeoff, so I can see what the tonnage, the expected tonnage is for each of those reinforcement within that pile. Now, if we're comfortable with the pile design, and perhaps we've had a geotechnical engineer to come and review it, and we're happy with those capacities, we can then move into ProtaStructure and look at how they may be applied. So here's a simple building structure that I've created, and at the floor 0 you can see the basic foundation. Well, what is the foundation would be the foundation level. So in here I can come and select, say, some perimeter columns here, and if I right click, I then have the ability to be able to insert a pad base, or in this situation I might look at a pile cap. So I'm going to choose to insert a pile cap, and it will then list those columns with the associated loading for the design. Now, the foundation settings are all centralized, and in here I can come and choose the pile cap, and we can define some basic parameters. For this situation here, we had an allowable working load before of 150, and I've preset that the pile size is 225. Okay, it's circular. We can play with the spacing factors, so if you want 3 or maybe 2.5D, these can be defined by these. You can predefine these. So if I hit OK, I can then ask the software to batch design these in one go. So at this point, it's optimizing the depth of the pile cap as well as the reinforcement. It's coming up with the most efficient arrangement that it can. Now, the number of piles is indicated here. It's finished the design. The number of piles is indicated here, and what we can also do at this point is look to group them. So if we choose grouping, it will find pile caps which are similar both in size and number of piles, as well as the column arrangements above. So I've now grouped these, and if we're happy with that, if we then hit OK, it will then apply those foundations into the model. Okay, and you can see different configurations here. If you click on this, you can see the associated group there. Okay, this is an individual pile cap. Okay, again, this might be an individual pile group as well. Okay, now if we do select the pile cap, we can come and have a look at that in more detail. So we can see a basic schematic of the pile. Okay, the pile locations are also indicated here. We can look at what material properties we've defined, okay, and also the different theories that have been used to check the pile cap. Now, we're using cantilever theory, and we also take advantage of deep beam theory, as well as punching and shear checks to code of practice. Column loads, both axial as well as biaxial bending and shear, can be input. You can also assign user-defined loads if you wish. And we are then calculating the axial loads in every pile, and you can see the capacities here. Now, for a given pile, you might find you get to site and actually it doesn't actually wind up where you want it to be. Okay, and maybe it's moved slightly. So within the system, we can also type in any deviations that may occur, and we are instantly checking these to see whether they still comply with the code. Okay, and if you then want to create the pile cap, you can then see that the as-builts are then provided to you, and you can see the as-built locations of the piles there. So that is a pile cap. Perhaps over in this corner I might actually want to, in this situation, put in a pad base. So we can come in and key in a pad base. You can start by defining a depth that you might want to start with. Okay, all the loading and data has been populated, and if I just calculate, it will then work out the allowable, the size of the pad base required. Okay, now you can predefine the allowable working bearing capacity, okay, and it's gone around and worked that out. Now you could change that to perhaps a square footing, and you can see that that is instantly recalculated. If you have slight eccentricities, you can move the position of the pile of the column around to give you a desired result. Perhaps you're close to the boundary and you want to recalculate based on a different eccentricity, then we can take care of that. So if you hit OK, then you can then see that the pad foundation is then applied at that location. Now I'm going to look at something a little bit different here. If you have two columns that are close to one another, you do have the ability to be able to combine these for combined foundation design. And we can come in here and can look at inserting a pile cap, okay, and we can ask it to design, okay, and I may move into in this situation here, I may want to change the allowable working loads. Okay, I don't have a particularly large loading in the pile, and maybe I'm happy that that pile might be slightly less. So we can then come in and make that change, and then it will come in and automate the design. If I hit OK there, you can see that it's then come and tried to define the pile cap there. Now I only need 2 in that situation. I can come and edit this if I did want to make changes here. Okay, we can open this out also, and then make changes to the design. Okay, so in this situation here, I may want to change it to a 4 pile cap. If I wish to, I could do that, and then I can apply that at that location as well. So the choice is yours as the designer as to what you might want to provide. Similarly here, in this situation here, we may want to combine this again, and in this situation I'm going to insert a pad base. Okay, so again I can calculate that out, it's worked out what's required. Okay, I may need to iterate this a little bit. Okay, you can see that the shear is not quite passed there. Okay, we may want to make the pile cap a little bit thicker. Okay, and we can recalculate that. That's now satisfied the code. You can see the reinforcement requirements there. And if I hit OK, then that pad base would be created. Another foundation type that you may want to explore using is a strip footing. Now to create a strip footing within ProtaStructure, the idea is that you just come in here and input a concrete beam. Okay, you can play with the how the beam is placed. Okay, and you'd just define some basic parameters here for the depth and so on to help you outline that. So the idea is you put the beam in at that base level. Now if you then select it and right click, you have the option then to insert a strip footing. Okay, and in here you can then play with strip footing parameters. So you can work with different spring stiffnesses. I might want to step the foundation through a range of different spring stiffnesses for the soil. Okay, we can come and do that here. Sorry, to say 50,000. Okay, and we can step through a range of different spring considerations here that we might want to look at. Okay, the footing can be eccentric, so again you might want to offset it. You may also want to introduce a taper here. You can introduce tapers to pad foundations as well, and I'm going to design this based on an envelope. Okay, so if I then just ask it to design, it'll go away and look at the envelope of forces. It will create an envelope here, and the design will be prepared. Okay, so if I'm happy with that, then you'll then see that pad foundation is now designed. Now if any of these views, if you come in, you can see that as I've been creating these, the foundations have been applied within the model. Okay. So the last thing I may want to do in here is come in and design our foundation beams. So this foundation beam here, we can then ask it to batch design that. Okay, and in here we can come in and check the Raft foundation. Okay, so you can see you can get a quick look at what the drawing may actually look like here before we move to document it. Okay. The next thing I may wish to do within here is to create a raft foundation. So to do that, I can define an outline of where I want to place a raft, and then I may want to insert a slab. So in this situation, let's assume that the raft is 500 thick. We can then come and define and place that raft within the model. Now if I wish to design the raft, I can selectively choose to cut finite element strips through the raft foundation, and I can cut these strips as integral strips in X and Y. So you as a designer may choose where you'd like to locate these strips, and you can then cut the strips accordingly. Maybe I want to cut a strip through this locality, and perhaps I'd like to cut a strip through at the midspan there. Okay. So once I've done this, we can then move into running a finite element raft foundation design. I can put in my allowable spring stiffness if we're not sure. There's some handy guidance from Bowles here on spring stiffness coefficients that you may wish to use, or spring stiffness values you may wish to use. And once I've done this, I can then move in and start to mesh the floor. Now you can, if you wish to, include the column sections in the FE model. You can ignore the bearing capacity of the soil, so that may be in a situation where you have a piled raft. You can come and manipulate those settings here. But I'm just going to mesh this, okay, and then I'm going to move in and mesh this. So if I just ask it to mesh, it will then move in and mesh the raft. What you'll also notice at the same time is it's also meshed those other foundations that we have in here. And if I just close this down, it will then move in and run the FE analysis. So post-analysis, we can come and have a look at the results here. And you can come and interrogate this. So I might wish to look at my basic deformations. So you can see there's a legend here with a range of deformations. My maximum displacement for this foundation is about 7 millimeters. I may be okay with that. Okay. I can also just come in and just focus just on the raft foundation itself. So in here I may wish to look at the moment in the X, my moments in the Y. We also calculate wood armour effects, so torsional moments within the slab will be calculated, and they will be resolved into both X and Y directions. Finally, we can also look and get just a feel for what kind of area of steels may be required here. Okay, and if you click on the top, okay, you can see the range of reinforcement that is likely to be required in the raft, okay, as well as in the bottom. So you can look at those in different directions. If you do want to look along a strip in more detail, I can just come and choose it from here. So I may wish to look at the strip, integral strip along strip Y1, and you can see there that it's integrated across the strip width here, and we can see those forces here. So I can look at displacements, I can look at moments along that strip, I can see design moments where we resolve the torsional moments into the X and Y components, and we can also see the required area of steel here. Now you may also at this point want to look at your contours for soil pressure. So you can come in and choose to look at contours. You can have user defined contours here. You can edit these. So if you had a range of stress here, you can choose to define the stresses. Now if you had a threshold contour where maybe the maximum allowable stress within the soil, perhaps an ultimate stress might be 300 MPa, and if you select that, then the software will tell you where that's exceeded. So in this situation for this raft, it's not been exceeded. In other parts of the foundation we may have a problem. So if I was happy with that, I can then move to transfer those results back for the design and detailing. So it's now just taking those results, and they've been transferred back into ProtaStructure. Okay, and once we've done this, we have the ability in here to be able to then update the steel bars. And you can see here it's now applied as reinforcements. across these the strips that we've had, and you can see what reinforcement may be required at different localities in the strip foundation. What we may also do is, if we just select this, is that we may also run a punching shear check. Okay, and we can come in here and predefine the reinforcement that we may have in the raft. Okay, and that can be done throughout. So we may have 16 bars. Okay, in X and Y. These can be assigned. Okay. And we might set those as a minimum, and then we can ask it then to design check. Okay, so this is now checking for punching shear. Okay, once it's concluded the check, it will then prepare a report where you can see the punching shear detailed check results. Okay, in this situation here, I'm checking these to the Eurocode. Okay, and you can see whether or not these are adequate or not. So it's checking both local bearing as well as that 2D from the code, from the face. Okay, and if any additional reinforcement is required, then you would be advised here. Okay. Now, if you decided that perhaps in this situation here, these that the foundation system that you have proposed wasn't adequate, you can come in here and make changes to it. So I could select this foundation, and what I'll do, just for the instance of clarity, is I'll remove these design strips that we had created, and maybe here, if I just select this, I do have the option to insert a pile within the raft. So I could choose that and select the pile. Now this thing gives you a locality that you can work with, so I can choose to offset that pile from this corner, which I've first input, and I could come up and define an arrangement of piles here. So I've set out the pile arrangement. I can play with the spring stiffness and the type of pile that we may want to include here. Let's assume it's a 150 diameter pile spaced at meter centers. And if we hit OK, this will then provide you with an arrangement of piles beneath that raft. Now this is fully editable. If you wanted to make changes to this, if you decided that these piles that I've got here I don't want, okay, well these can be removed, and you can come and take those out. Any of these piles in here you can remove if you don't wish to have them. Okay. Now the other great thing about this is that all these piles are editable. So if I want to make a change, perhaps this is a square pile, not a circular. Okay. I could change the properties of this, I could change the location of this pile. This can be moved about to suit, okay, and I can just reposition that accordingly. Now if I go back to the analysis, the finite element analysis, I can run that again. We can continue to cut our strips again within the model. I'll just show you that quickly. So we could go back and remesh this, okay. This time round it will include the pile, okay, and we can mesh this up and perform the analysis. Now, in addition to what we had earlier, this time round I may just want to take a look at the actual pile capacities. Okay, so within the Raft Foundation here, okay, you may notice that there are the pile locations have been indicated there, and we can look at soil pressure here. So if I just turn off the contours, you may just be able to see that the piles there are all indicated in green, and if we found that any piles were exceeding the allowable loads that we may have predefined, then these will turn red. So very quickly there you can see whether or not in this situation here that pile arrangement may be okay or not. Now do note that when you do use finite element analysis, the Raft Foundation becomes flexible. It's not a rigid cap. So you may find that loads may migrate to piles which are placed directly under columns and foundations. So making sure that you take that into account in your design assumptions is important. Okay. So at this point, once we've actually completed the foundations that we want to design, we can then move back into Proto Details and start to document these. So I'm just going to come to the menu here and load up Proto Details, and we can then move in and just create all the foundation information using Proto Details. So just quickly load. Okay, I'm going to take advantage in here of the auto generate feature, and I can then selectively choose what I want to create. So in this situation, I'm going to create the I can create the key plans as well as the foundation details here, and I can selectively choose what I want to create. I might just want to focus directly on the foundation level. Okay, there's various settings in here that you can work with to adjust information here, and different options that you can work with. Don't forget though that you can come in and you can choose to insert these into your title block. Okay, you can choose your drawing sheet here, and you can label things accordingly. So in this situation, I may want to call my key plan, say, foundation plan, and I could give it a reference. I can then hit OK, and then we can ask Proto Details to just draw all of this up. So if I just click at a button, it will then go away and automatically create all of our drawings for us. So you can see here it's nicely laid all the foundation details out into sheets. If I just zoom in, here you can see our foundation key plan. Okay, so you can see all that information that we were working with before has been set out here. Our eccentric pile cap information, our raft foundation, our combined foundations, strip footings and so on is all nicely referenced into that key plan. And this is laid directly into your title block, and I've labelled that foundation plans as you saw earlier. The other nice thing about this drawing is that it also can show information like dimensions against grid. So if you're wishing to use this for set out on site, then you can easily achieve that. You can then move in and have a look at the details more closely. So I might want to see our strip footing details. Everything in here is quantified, so you know for these elements exactly what the takeoff is. Okay, we could also come and have a look at our pad foundation designs there. Okay, there's our eccentric base. We could also come down and have a look at the actual pile caps here, so you can see views of the pile caps, and you can see how these are all being nicely detailed out. Okay, remember that you are in CAD, so if you decided that some of these details you wanted to reposition, okay, you can just pick up details in here and just replace them. So if I decided that I thought that these details at the bottom here were just a little bit too close, okay, I could just grab these, and then we can move these and reposition them to suit what we would like them to be within the drawing. Okay. Again, all this is quantified, so you've got accurate quantities takeoff here. These are objects. All of this is all these relate directly to the elements in here. You can come and manipulate these bars if you wish to change sizes and so on. They can be adapted in here as well. What you can also do in here is that what you'll notice here is that on the left here, all the information, pile cap details and the like, is all nicely shown in the tree here. So if I just wanted to come and grab a particular pile cap, okay, we could then pull that out and draw that independently. So this is this pile cap that we did earlier, where the pile is eccentric. We will also create against this pile coordinates, so you can see offsets. So if you're having to submit as-built drawings with pile eccentricities, they can all be created for each of the foundations within the model. So as you can see, very quickly we can create all the underlying drawing documentation inside of Proto Details. Okay, we can look at all of this individually. As I mentioned, you do have access to the details in the tree here. If you did want to just come and draw out all the pile cap details one by one, then there's handy tools to enable you to do that as well. See, I'm just clicking here just to quickly create every single pile cap, and those include those eccentricity tables. So just quickly, you can create whatever you like from the tree here, but all of this has just been done in a seamless way, laid into your title block sheets for you to start to produce all your drawings. Now the other thing that you may also want to do at this point is collate all the design into a documentation. So to do that, we have a report manager, and I can just load the report manager here. Now progressively as we've been going, as we've been designing the foundations, we've actually been creating different design data or reports, and these are loaded into the report manager here. So here you can see that for the foundations, part of the structure, there's various reports that are available depending on what you have done, and they can be organized into a report here. Now you can easily just compile these, and then I can then view the report. So I'm just going to build this report, and it will compile all the pile reinforcement design that we started with, strip footing, pad footing, pile caps. All these will just be lumped into one seamless report. So you can see here there's a table of contents created here that list all the different parts of the report here. These headings here, and you can just quickly look at different parts of the report here just by clicking on these headings. So if you wanted to look in detail at the pile design report there that we were working on earlier, you can go and look at different sections of this report, make sure that you're happy with the output. Similarly, if I wanted to look at the strip footing design, I can go to this part of the report, likewise with the pile pad footings as well as the pile caps. So you can, all of this is organized in a nice neat manner into the reports here, and these reports can be exported out to Microsoft Office, or you can PDF these. Okay, now the reports are adaptable, so if you want to move things around within a report you can, and then you can just recompile it. You can also bring other information into the reports. It's entirely up to you. It's very flexible, but it's very fast and very easy to be able to document whatever is created in here. Now finally, if I did want to move into starting to look at more advanced capabilities, particularly with things like merged foundations, within the foundation model I can merge the foundations together with the building analysis, okay, and we can move to run the analysis again. So if I do run this again, it will then take the building structure, the superstructure, and it will combine it with the meshed foundation model that we created earlier into one complete model, and we can then assess the behavior of the model and look at soil structure interaction. So post-analysis, we can review the results now with the foundations combined together with the building model. So I'll just open this and I'll give you a quick preview of what you could interrogate in the model. So here you can see our physical model. I've meshed various components within this, but as you can see the foundations have also been meshed. Just note that we don't include the piles in the mesh, so they are being treated as springs, and you can then start to look at things like contours. So if you want to see the contours in the mat foundation there against the shear walls, seed nodes will all match, so we mesh this properly so that things are properly connected. And then here you could start to look at different stresses and contours in the walls, depending on what you want to review. You could also look at resultant displacement. So here I could review the foundations, and we could see how they're behaving under those given loading. So here you can see in this model I've got a maximum displacement of about 15 millimeters for parts of the structure. Okay, so in this way you can take advantage of the technology just to start to look at things like soil structure interaction as well. Integrating the foundation model together with the building analysis model. So I've covered a bit of ground with today's presentation on foundations in ProtaStructure, and we covered a wide range of different foundation types. You saw pile, pad, strip, combined foundations, pad and strip footings, rafts, and we even touched on pile rafts. We also looked at soil structure interaction briefly. at the end. I also covered how this can be documented into Proto Details. Proto Details is obviously our system for drawing management and arranging everything into your sheets, as well as having full drafting capability. And we can selectively choose how we want to draw things up in Proto Details, as well as providing you with handy information like quantities takeoff. So we also looked at the documentation behind that with the report manager, and you saw how all the different calculations for various parts of the foundations can be created and all nicely presented and reported into the system. So on behalf of myself and the Prota team, I hope you enjoyed this session on foundation design. Please check out our website www.protasoftware.com and you'll see more exciting presentations to come in the future. I hope you enjoyed today's presentation, and we look forward to bringing you more fantastic technology to come.